the extended law of sines.
This video is paced rather quickly, so please pause it to analyze the work every time you see this symbol in the upper right-hand corner of the screen. So our claim is that the law of sines is actually equal to 2r, with r being the radius of the circumscribed circle for any triangle. The circumscribed circle of a triangle is the circle which passes through all the vertices of the triangle. So we'll set 2r equal to d, d being the diameter of the circle. We then construct an ambiguous triangle ABC inside of a circumscribed circle S. A line is drawn straight up from point C to intersect the circle at point E and form a right triangle. We also set angles alpha and epsilon congruent to each other. So we know that line segment BE is the diameter of circle S, so line segment BE will be called D from now on. We used right triangle trig as well as substitution for angles alpha and epsilon to derive that sine of alpha is equal to A over D. Next, we do some simple arithmetic to derive that d is equal to a over sine of alpha. Since d is equal to a over sine of alpha, we can use the transitive property to set d equal to the entire law of sines. We know that the diameter is equal to 2 times the radius, meaning that d is equal to 2 times r. So now we can substitute 2r back into our equation to get the extended law of sines. 2r is equal to a over sine alpha is equal to b over sine beta is equal to c over sine gamma. And of course, no proof is complete without its box. Baylin and Tran's pie problem. Mr. Baylin lives on the crust of a pie. It's getting close to Thanksgiving and he wants to go get pies with Mr. Tran. He drives to Mr. Tran's house, which is also on the crust of the pie. They then drive to Julian's Pies, forming a 35-degree angle from Baylin's house to Tran's house to Julian's Pies. After picking up their pies, they make the 50-mile drive directly from Julian's Pies to Mr. Baylin's house. Once they finish eating, it's time to go to math club at BHS. Mr. Baylin knows that BHS is directly across the pie from his house. They leave at 3:50 p.m., but math club starts at 4:30 p.m. They speed directly to BHS at a constant rate of 60 miles per hour. What time will they arrive? Will they be late? Will the students have already broken into the Pocky stash? Let's draw a diagram. Here's a pie with Baylin's house, Tran's house, and Julian's Pies. Here's the triangle that connects them all, and here's BHS. We'll draw that line straight up from Julian's Pies to BHS as well to form the diameter with Baylin's house and the right triangle. We know that the angle formed at Tran's house is 35 degrees as well as the one at BHS. We also know that the distance from Baylin's house to Julian's Pies is 50 miles. Now we just need to find the diameter, d. Luckily, we have the extended law of sines, which tells us that t over sine of theta is equal to 2 times the radius, which is the diameter, d. We then solve for the distance of d in miles. We now use the speed of 60 miles per hour and the distance we just got to calculate the time it takes to get to BHS. We then do some simple conversions to find how many hours and minutes it will take, and then we add that to the time at which they left to find that they will arrive at 5:17 p.m. This implies that they will be late, but of course no students will have broken into the Pocky stash.